We all know that signal integrity can cause problems in high-speed circuits, but checking it can be a hard thing to do, even with a scope. XJTAG software, though, has a nice feature that can give you an indication of what your system's full speed performance is like without needing any extra test equipment. It's called Get Max T-Clock, and it will check your JTAG interface to see how much safety margin you've got on the T-Clock frequency. The button for it is down here at the bottom of the screen. I'm running it from inside the JTAG chain debugger, but you can use it equally well within XJ Developer. When it runs, you can see that it checks the chain first and then increases the clock speed as far as it can before it starts to see errors in the returned data. Once it's finished, it will show you the maximum frequency it achieved. What you need to do now is to compare that to the quoted maximum frequency for the slowest device in the chain. You can find that either directly from the BSDL files or from XJ Developer. To view the BSDL files, you'll need to open them in a text editor and scroll down to the TapScan clock attribute, which provides the figure you're looking for in Hertz. Do this for each device in the chain to find the slowest. Alternatively, if you're using XJ Developer, simply open the JTAG chain screen that will show you all the parts with their stated maximums. The thing to note is that this figure is the guaranteed frequency across the full temperature range, and you ought to see a very good margin between what's quoted for the slowest device and what the test software can achieve at room temperature. For example, if a device is guaranteed to 10 MHz, I'd expect you to see something in excess of 20. If you've got that sort of margin, you can have confidence in your system and just need to do some final soak tests. If your margin's much less than that, say only a few megahertz better than the guaranteed maximum, then your system could prove unreliable, and you need to spend some time now investigating its high-speed performance. You may also want to watch the first video in this series that covered grounding, pin-out and termination resistors, all of which can affect it. Also, please don't be tempted to solve signal integrity problems simply by lowering the T-clock frequency. Such problems can have a variety of causes, including terminations, signal rise and fall times, and so on. Reducing T-clock to try to fix issues like that without investigating and identifying the reason is never recommended, because it can leave you with random test failures. Any signal integrity issues really do need to be addressed. If you need to look at your signals with an oscilloscope to check for things like ringing, remember you can use the Scan ID codes feature that we spoke about in video 5. If the signals look good on a scope, but you've still got a problem, you might have an issue with crosstalk, in which case the signal integrity test I'll be demonstrating in the next video may be helpful, because it uses sequences specially designed to provoke crosstalk issues. Once you've made any necessary changes and have got a sizable margin over the maximum frequency, you're ready to use XJ Developer to get your tests running. When those are all error-free, you're almost ready to transfer into production. But there's just one more test we need to do to prove the long-term reliability, and that's the topic of the next video. Thank you for watching. If you found this video helpful, please subscribe for more and leave a like or comment below.